Now, what's the probability of winning from a state? It seems complicated. It seems like we got a lot of work to do, but actually we've almost solved the whole thing. All we have to do is say, what's the endpoint? So remember, we start out in the start position, and then we have some end positions where the game is over, and we have to assign utilities, which is the same as probability of winning, which is either 0 or 1. So this is a losing state, so it gets Pwin of 0. This is a winning state, it gets Pwin of 1. We assign all those, and then all the other states that depend on these, we've already figured that out in terms of the Q function. Let's see how that works. So the probability of winning is 1 if my current score plus the pending is greater than or equal to goal. Then I win automatically just by reaping those pending. My probability of winning is 0 if your score is greater than the goal and I haven't won. And otherwise, my probability of winning is the probability that I get by taking the best action. So for all the actions, among all the actions I can do, look for the Q value of that action from the current state according to the utility function. Try to maximize that, and that's going to be my probability of winning. So that's saying I can make the best choice that I can. So we said that we had 3 choice points. Here, I'm making the best choice by maximizing. Here, the die gets to roll, and we're averaging. We're summing them all up and dividing by 6, so that takes care of the averaging. And what about the worst choice that the opponent makes? Well, that's just folded in, because rather than sort of explicitly worrying about me and my opponent, I just said, well, I can use 1 minus the probability of me winning. That's the probability of the opponent winning.